All right, so right now I'd like to talk about section 0.3, equations and inequalities. Your suggested exercises are going to be 5, 9, 19, 23, and 27. So with equations and inequalities, this is of course a huge topic we could spend a lot of time on, but I just want to do some really basic examples. Again, I would ask that you at least flip through the text, maybe read some of the later stuff a little bit more carefully, but at least flip through the text. So let's do a couple of quick examples. So when I've got an equation, I'm probably going to say something like 3x equals 6. Okay, that's an equation. Now this is just an equation. It's doing its own thing. There's nothing more to be said about it. Oftentimes, however, we are asked to solve an equation for a particular variable, and that means to find all values of the variable that make the equation true. So solve for x, 3x equals 6. Well, then this, we have to find a solution. So we write 3x equals 6. By the way, I recommend, even though I know the problem is written down right here, I recommend writing it down again. There are a number of things this is going to do. As you write this down again, 3x equals 6, it sears it into your mind. And you have to carefully look at the original statement to make sure you don't slip a minus sign or something. But also, it ensures that you're messing with the right pieces. And that, because when we want to skip steps and modify it as we write it down on the next line, that's a great place to make a mistake. Okay, now 3x equals 6. I'm going to divide both sides by 3 so I can get the x by itself. Now here I want to recommend that you don't just write equals x equals 2. Okay, because this is not an equal sign here. Now something that's permissible, and that you might see me doing from time to time, you might see me saying, oh, right arrow, so this is a big arrow, x equals 2. That's fine. And x equals 2 is the answer. It's just that I don't have 3x over 3 equals 6. Just writing equals x equals 2, while it's not, I guess in this case, it is strictly speaking equal all the way across here because I divided both sides by 3. But this is just not good practice. Okay, so please don't just write equal signs across. That's just, oopsie daisy. Got way too excited with this. So please don't do that. But the answer is x equals 2. Another thing, if you put your answer in a box, if there's like a long derivation, if your answer is in a box, then it's a little bit easier for me to see what your final answer is. Because if there's work covering the whole page, sometimes it's tough for me to tell where you stopped. So let's do another example. This one was pretty straightforward, but let's solve for x. And let's do, let's say 4x minus 7 equals 9. Okay, so solution. We write the problem down, 4x minus 7 equals 9. Now let's do something to both sides. Let's add 7 to both sides, let's say. Okay, see here, this would be a horrible time to say equals 4x equals whatever. That's just, it's not classy. Let's avoid that. Now, if you want to do all of your work on the same line, you can use this big arrow that's saying pointing to the next step. That's fine. 4x equals 9 plus 7 is 16. Now I can divide both sides by 4, and this leads me to the next step, which is the solution x equals 4. That's fine. Okay. So presumably, after doing a couple of examples, you're like, yeah, I know how equations work. So let's do an innocuous looking solve for x, and let's suppose we get 4 over x minus 2 plus 1 equals, say, 2x over x minus 2. And if you could, just take a minute, maybe pause and try to work on this, okay? Just take a short amount of time if you could. I'm going to take a sip of tea. Now, hopefully you've just unpaused the video after spending some time trying to hack through this. So let's go for it. Let's multiply both sides by x minus 2. So I've got 4 plus x minus 2. And then on the right-hand side, I multiplied this by x minus 2, so I just have 2x here. Let's simplify this. I've got, so 4 minus 2, so this is x plus 2 equals 2x. I can subtract x from both sides, and I get this final answer that x equals 2. And, I'm going to sip my tea again. So what's our final answer? Am I going to put that in a box? No, the answer is no solution. Why is the answer no solution? Well, let's look. If 2 equals x, then I've got to divide by 0. What happens when you divide by 0? Bad things happen. So x cannot equal 2 because we cannot divide by 0. Okay, that's breaking the rules. So the final answer here is no solution. Now, I'll give you that was a little bit tricky, but you want to make sure that when you get a value for x, that it makes the equation true. And if we're dividing both sides by 0, or if we're dividing by 0, I don't have a definition for this side. So I don't know whether they're equal or not because they're not defined. So if that's annoying, that's too bad. This is how things shake out. So if I don't have a well-defined number, then I can't say whether or not it's equal to something. So if you make a mistake like this, I probably won't freak out, but I will count off some points for missing something like this. So that's a little bit of review of equations. Let's do a couple of things with inequalities now. So for inequalities, it's going to start out kind of like an equation, but with a couple of wrinkles. So let's solve for x. And I've got, let's say, 2x plus 1 is less than or equal to 5. So solution, I'm looking for all of the x that satisfy this inequality. So I write 2x plus 1 less than or equal to 5. And I can just treat this like an equation, but write this less than or equal to sign instead of an equal sign at each stage. So 2x plus 1 less than or equal to 5. I'll subtract 1 from both sides. So I get 2x is less than or equal to 4. Divide both sides by 2. And I get x is less than or equal to 2. Now this is a fine answer, but I want to show you some other ways to communicate x is less than or equal to 2. So one thing we can do, and I mentioned this in class last time, but I don't think I put this on the YouTube video, but I can list this as negative infinity up to 2. So what this is saying is x is bigger than or equal to negative infinity, which all real numbers are bigger than or equal to negative infinity, and less than, all real numbers are bigger than, strictly bigger than negative infinity, and less than or equal to 2. So this is another perfectly correct answer. Another thing you might do is give me a real number line. We'd like to see 0 on the real number line if we can. And since 2 is a possible value, we'll color it in. And I like to just come over the top like this. Some people like to sort of scribble this in to indicate that we're going to the left. So this is, again, another fine way to communicate this solution set. Okay, so that's just a really quick, basic inequality. Now, inequalities can get nastier. Suppose we have solve for x. Let's say negative 2x is greater than 3. Okay, negative 2x is greater than 3. Let's solution. If I have negative 2x is greater than 3, and this is a strictly greater than, I'll just divide both sides by negative 2. Okay, that's fine. But what happens when I multiply or divide an inequality by a negative number? Well, then I've got to flip the inequality the other way. So then I have x, where it was greater than, now it's less than negative 3/2. And this is my answer. So we need to remember to flip if we multiply or divide by a negative sign. Okay, now the last two things that I want to do are if I have sort of multiple inequalities together. So sometimes I have something like, let's say 4 is strictly less than 2x, which is less than or equal to, let's say, 12. So I can, in this case, work with both inequalities, because this is actually two inequalities, right? This is written on one line, but here's one inequality, and here's another inequality. So I can work with both of these inequalities at the same time by just writing, well, I write 4 less than 2x less than or equal to 12. I'll divide all parts of the inequality by 2, and I get 2 is strictly less than x, which is less than or equal to 6. Okay, and again, if I wanted to write this in interval notation, so I would write 2 with a parenthesis because this is a strict inequality, and then 6 with a square bracket. All right, I could also do this on the real number line. I like to put 0 in, then I put a 2 and then a 6, and I can do a hollow circle there and a filled in circle here, and either, color that in, or I like to just draw a line over it to indicate this. So these are all perfectly fine ways to indicate this set here. This topic gets a lot more complicated, and we could go a lot further with it, but I really just want you to have this as kind of the basic idea of how things work. So we could combine this with negative signs and other things, and combine it with adding and subtracting, and it would get nastier, but maybe we'll just stop it here for this. Go after the homework and contact me.